Hello viewers, I am Kausalya. Today we are going to discuss about open circuit and short circuit. So again, consider these two circuits, right? So here when you compare these two circuits, what is the difference? The first circuit has a voltage source, right? And a current I flows through it. And here we are having a load. Okay, here the load may be a fan, a light or whatever may be, right? So here when you compare this second diagram, the load is removed, right? Can you notice it here? The load is totally removed here. So here it is kept open. That is why here we are mentioning this circuit as open circuit and this is a closed circuit or simply circuit, right? So as we all know, the current always flows in a closed path, right? You see here, it starts at A, it flows through or it flows through this load and again comes back to B and again reaches this A. So here the current flows, right? Whereas consider this circuit. So in this circuit, what happens? This is a open path, okay? So what happens? There is a no current flow in this circuit, but there is some voltage across this open circuit terminal. That is when you kept a voltmeter and measure the voltage across these two terminals, you will be having some voltage. It won't be zero, right? So this is what explained here. If the circuit element or load, right? Load is mentioned here as circuit element. It may be of any type. Either it may be a resistive load, inductive load or capacitive load or a combination of all these three or combination of any two, right? If the circuit element is removed from the circuit, right? Here this is what done. So here the circuit element is removed here and the path is kept open, right? Here the path is kept open. So it is known as open circuit, right? So when we speak mathematically, the current flowing through this path is 0 and voltage is not equal to 0. This is what mentioned here, right? Now we are proceeding, we are going to explain this concept in detail by considering another two circuits here. So in this case, you see, again, this is our circuit, first circuit, and this is our second circuit. So what is the difference between these two circuits? In the first circuit, we are having three resistors, namely R1, R2, R3. Whereas in the second circuit, we are having only two resistors, R1 and R2. Right. And addition to that, now let me discuss about the number of closed paths which are available in the circuit. So when you consider this circuit, we are having one. Okay, this is your first closed path and this is your second closed path. So totally two closed paths are present here. When you consider this circuit, here we are having only one closed path because here it is open. Right. Now let's proceed with the current here. So for example, let the total current flowing through the circuit be 5 amps, right? This 5 amps current, it gets divided into 2 at this point, right? This point is known as node. Here node is nothing but a point where two or more elements get connected, right? So here to this node, we are having three resistors which are connected here, right? So this 5 amps when arrive at this node, it gets separated into 2 amps and 3 amps. This 2 amps and 3 amps depends upon the resistance value here, R2 and R3, right? Whereas when you consider this circuit, again the current 5 amps comes here and reach this point, right? So at this point, again you see, here it is an open circuit. So as we just now discussed, no current flows through the open circuit. Therefore, this entire 5 amps current starts flowing through this R2, right? Am I making the concept clear here? Here you see the circuit is closed and here we are having totally two closed paths, right? One is this and another one is this, right? But here there is only one closed path. So since here we are having two closed paths, when the current reaches a particular node, here it gets divided into two. Right, but here in this case, there is no path for the current to flow other than this, because here it is open circuited, right? Even if we didn't draw these lines, the meaning of the circuit holds the same. Do you agree or not? So the same 5 amps current flow through this resistance R2. Right. So I believe these circuits have given you a clear explanation about open circuit. Right. The key things you have to keep in your mind is, in an open circuit, the value of current is 0 and the voltage is not equal to 0. That's it. Right. The next topic is short circuit. So what is meant by short circuit? Again, consider these two circuit diagrams. Right. So the first circuit has a voltage source and a load, and a current I is flowing through this circuit. Whereas here in this case, the load resistance, that is the load, is totally removed, and here these two ends are connected by a conductor here. Right, a conductor is nothing but a wire. So what happens here? Again, can you tell me whether this is a closed circuit or an open circuit? Here in this case, both the circuits are closed circuits. Right. So in the case of closed circuit, what happens? There will be some current which is flowing. Right. So here the current is flowing through this circuit, whereas the voltage is 0. Right. Why the voltage is 0? Because there is no potential difference between these 2 points. Right. So therefore here the voltage is 0. So mathematically writing, the value of voltage is 0 and the value of current is not equal to 0. Right. Again, to have a clear explanation, to give a clear explanation, I have chosen these two diagrams again. Right. So here this circuit consists of two resistors R1 and R2. Okay. And we are providing with the voltage source V here. Here in the next path, again we are having a voltage source, two resistors R1 and R2, but here we are connecting this R2, that is we are connecting a wire across this R2. In other words, the resistance R2 is short circuited. Right, I will explain how. So here the current I1 flows here, flows through this circuit. So this I1, when reaches this point, again the same current I1 flows over here through R2. Right. Am I making sense here? The current flowing through this R1 flows through R2 also. Right. When you calculate the total resistance of this circuit, here again these two resistors are connected in series. How do you came to know the resistors are connected in series? Because you see, the ending point of resistor R1, right, becomes the starting point of resistor R2. Right. So here in this case, these two resistors are said to be connected in series. And the series and parallel connection of resistors are totally, it is a different topic. Okay, I'll make a separate video for that. But here in this case, you just keep this in mind. The ending point of one element became the starting point of other element, means then those two elements are connected in series. That's it. But here in this case, again you see here the current I1 flows, and again here it reaches this point. Right. When it reaches this point, the current never flows through this resistance R2. It flows through this conductor or this wire. Why does it happen? Because the current always select the less resistance path to flow through. So here, for example, let the value of this resistance be some 5 amps. Here it is just a wire or a conductor whose resistance is comparatively negligible when compared to this 5 ohms. Right. So this conductor has merely low value of resistance. Therefore, instead of flowing through this R2, this entire current flows through this short circuit path. Right. So in this case, when you calculate the resistance of the circuit, the value of total resistance R is equal to only R1, because here the R2 is short circuited. In other words, no current flows through R2. The entire current flows through this wire. The reason is the wire has less resistance when compared to this R2. Right. Or in other words, we can say that the resistance R2 is short circuited. Right. So this is the end of this video. If you have any doubt, let me know in the comment section. Thank you.